So you guys have probably heard about pH before, and it was just numbers that we gave you and didn't really explain it. pH is a measure of how acidic or basic a solution is. The way that we do this is it's actually a calculation that involves the concentration of H or OH in your solution. So you should know from some former class or from some of the intro stuff we've done that the pH of an acid is 0 to about 7. 7 is neutral, so exactly 7 would be neutral. There's a little bit of a range that we go with. And the pH of a base is anything greater than 7 up to 14. And these are true because if you're less than 7, your H is greater than your OH. If you're more than 7, your H is less than your OH because of how the math works, which we're going to look at in a second. So by the way, because this gets asked a lot, especially in advanced, yes, it is possible to have a pH that is less than 0. It is possible to have a pH that is more than 14. But once we get outside that 0 to 14 range, stranger things tend to be happening, and those don't calculate as well. So we try to stick with things that are in the 0 to 14 range. We find the pH by taking the negative log. In chemistry, a lowercase p like this just means take the negative log of it. It comes from the French for power, which I'm not going to attempt to pronounce because I did not take French. Because logarithms, that's what log stands for, are all about finding the exponent that something got raised to. It gets talked about a lot more in Algebra 2. There are some things that we're going to talk about that you're not going to get why. When you get to logs in Algebra 2, it will make more sense. For right now, just hit the buttons we tell you to hit, accept it, and move on. If we're trying to calculate pH, P of H means take the negative log of H. If we need to go backwards, the opposite of log is 10 to the power of, because this is log base 10. If it was log something else, it'd be something else to the power of. But for right now, accept the opposite of this kind of log is 10 to whatever power. So this is how we go from H to pH and from pH to H. You can do the same thing with hydroxide. If we find the POH, it's the negative log of the OH concentration. There should be a negative there. The negative log of the OH concentration. And then the OH concentration, if you're trying to find that, would be 10 to the negative POH. If you notice, because of how the math works, the POH scale is going to be backwards. So note, if my pH for an acid is 0 to 14, that means my POH for an acid is going to be greater than 7 to 14. Greater than 7 up to 14. And my POH range for a base is going to be 0 to about 7. So POH scale goes opposite. A low pH is acid, a high POH is acid. All right, and so then to get between pH, or to get between hydrogen and hydroxide, there is a set relationship. pH plus POH is always equal to 14. And that's because the product of my H concentration and my OH concentration is 1 times 10 to the negative 14. 1 times 10 to the negative 14 is referred to sometimes as Kw. It's the ionization constant of water. The ratio of H to OH always sorts itself out, so the product of these two is 1 times 10 to the negative 14. The y on this, not terribly important right now. You'll get to it in a later chemistry class if you get there. All right, so our first use of this calculation is what is the pH of a solution if H, concentration, square brackets mean concentration, is equal to 1 times 10 to the minus 6th. So to find pH, we just said P is take the negative log of it. So negative log of 1 times 10 to the negative 6. You're literally just going to hit those buttons in the calculator. So we come over here, and I want to do, this is, remember, the Google Scientific Calculator. Negative, negative, hit the log button. 1, and remember, times 10 to the, we want to use the EXP. So 1 times 10 to the negative 6, close your parentheses. And we hit equals, and it tells us our pH is 6. It's less than 7, it's an acid. All right, so next one, it wants to know the OH if we know the POH. And so we look up here, remember, finding the POH is take the negative log. Going backwards, it's going to be 10 to the. So if my POH is 3.2, if I'm trying to find my OH, it's going to be 10 raised to the power of negative 3.2. And not accidentally. Sorry. So again, we're just going to type it in the calculator. So we're going to do 10. Gotta remember where. There we go. 10 to the power of negative 3.2. Do not try and use the EXP, even though we're doing 10 to a power. EXP freaks out if you try and do decimals. So this is my H concentration, or in this case, my OH concentration. So my OH concentration is going to be 0.000631 molar, because concentration is molarity. We could also write this in scientific notation as 6.31 times 10 to the, it looks like, negative 4, because you'd have to move the decimal place over 4 times. Whatever your calculator gives you is fine. Just depends on how your calculator is set up. Some will automatically do scientific, some will just give you lots of zeros. All right, let's try a couple more. If you want to pause and try these on your own, go for it. Otherwise, we're just going to watch through. This next one, it wants to know what is the H concentration of a solution with a pH of 3.2. Again, if I'm trying to go back to my H, I do 10 to the minus pH. So my H is going to be 10 to the minus 3.2. Hey, that looks suspiciously familiar. We just did 10 to the minus 3.2. So my acid concentration, in this case, is going to be this. Because 10 to the minus 3.2 is still 10 to the minus 3.2. The next thing it asks me, though, is how many grams of HNO3 would this solution contain? This is back to a 9-3 question. So I know a concentration. I can give a volume. I should have given a volume. So how many grams of this acid does, we're going to say, 400 milliliters of the solution contain? To do this, remember we're going to do dimensional analysis. So need some tracks. So remember, if you're given the choice between volume and molarity, start with volume because it only has one unit. So for 400 milliliters of solution, my molarity, remember, when we see big M, we replace it with moles per liter. So I'm going to need a couple more spaces. There we go. So if I got milliliters here, I need milliliters here. We know there's 1,000 milliliters in a liter. And molarity, remember, is moles per liter. So we know that 1 liter of my solution contains 6.1 or 6.31 times 10 to the minus 4 moles. Moles is not what I'm looking for. I gotta go one more step. And so the last thing I need to go is go to grams. And we know if we've got moles here, we put moles down here, and my grams always, always, always comes from my periodic table. And so if I look at the periodic table, I know that H has a mass of 1.01 plus N has a mass of 14.01 plus 3 O's, so that's 3 times 16 for a molar mass of 63.2. So 63.02 grams And so I just do my math. We're going to multiply everything across the top, divide by everything underneath. So, fun trick if you don't know it. Memory is a thing, history is a thing on these calculators. So 400 times my molarity times my molar mass, and the only thing on the bottom we need to divide by is 1,000. So 400 milliliters of this solution would have that. Would contain a mass of that many grams. We're going to readjust that. There we go. So it's all on one page. So that's the reminder that concentration really is concentration. We're still dealing in molarity. We could still do 9-3 kind of problems with things. All right, let's try another one. What is the pOH of the solution if it contains 5 grams of sodium hydroxide in 250 milliliters of solution? To find pOH, I've got to take the negative log of the concentration of OH. I don't know the concentration. I need to calculate the concentration. So remember that molarity is equal to moles divided by liters. Right now, I don't have moles or liters. So I'm going to need to convert both of these. So I need to convert my grams into moles, or I can't calculate a concentration. So this is 5 grams of NaOH. I need grams down here. And I know if I'm trying to get to moles, I need my mass from the periodic table. The molar mass of sodium hydroxide, by the way, works out to be 40. If you don't believe me, add it up. So 40 grams in 1 mole. So I divide this out, and I get, should be 0.125 because it's an eighth, but let's make sure. Yep. So my moles is 0.125 moles of NaOH. My solution is 250 milliliters. This one I don't necessarily have to do dimensional analysis because remember, we're dividing by 1,000, so we just move the decimal. 1, 2, 3. So it's going to be 0.25 liters. So to find my molarity, I'm going to do my moles divided by my liters. And that's going to get me a molarity of 0.5 molar. So now to find pOH, I take the negative log of that number. Which again, we're just going to plug it in, hit the buttons. So I'm just going to take the negative log of 0.5, close parentheses, equals. So that's my pOH. So my pOH of this solution is going to be 0.301. Notice, I'm not putting a unit on that. pH and pOH are legitimately naked numbers. There is not a unit to put there. Concentration is molarity. pH and pOH are just numbers. All right, last but not least, given an H of 5.5 times 10 to the minus 4 molar, find all of these things that we can find and state whether the solution is acidic or basic. So it's giving me my H, so I can just go ahead and put down my H. Next easiest thing is I can find my pH, because we know that to find pH, it's just the negative log of this number. So that's what we're doing on our calculator. We're going to do the negative log of 5.5. Again, don't forget your E minus 4, close parentheses, gets us our pH. So that's going to be equal to a pH of 3.26. Next easiest thing, it's the easiest calculation, we haven't covered it yet, we said that pH plus POH equals 14. I just found my pH. So if POH plus pH gives me 14, then 14 minus my pH is equal to my POH. So we're going to do 14 minus 3.26, which is going to equal, and again, history is your friend. That's going to give me a POH of 10.74. And then last but not least, it wants my OH concentration. Remember, OH is just 10 to the minus POH, which we just found our POH. So we're going to do 10 to the minus 10.74, which is going to equal, oops, don't forget your minus sign. So 10 to the minus our POH, and this is one where it's going to automatically go in scientific notation. We've got 1.82 times 10, because that's what our E means, to the minus 11. So now we found all of the things that we can find. The one calculation we didn't do is calculating our H and OH in relation to each other. It's relatively easy, but kind of annoying. If I can do it, we'll go through the pH, POH step. But you can go the other way around if you want. So I know all of this information now. I've got to decide if it's acidic or basic. Easiest thing to decide acidic versus basic is look at your pH. Our pH is 3 and a bit. That is definitely less than 7. Any pH less than 7 is going to be acidic. You can technically figure it out from your POH, but using the scale backwards tends to mess with people. When in doubt, if you're trying to decide acidic or basic, check pH. All right, so that's a little bit of everything that you can do with our pH calculations. Make sure you have made note of all of your formulas that you can use in case you need them. But that's a little bit of everything. Don't forget your log button. Make sure it's log and not ln. That's a whole other thing we're not going to get into. So from here, you can work on your pH calculations practice. You ask questions of your teacher if you're still stuck on something.